Hello class, I hope everyone is doing well when they start watching this video. We're going to start talking about our periods of the periodic table. So we've learned a little bit about the basics of our periodic table. We've learned about atoms and what they look like, and now we're going to start talking about how our elements and atoms change as we go through different parts of our periodic table. So again, some questions to get us thinking. Does anyone remember how many rows are in our periodic table? We actually have 7 rows, or we call them periods. And then I'm curious if we can think through how this would change as we go across the same row. So let's take row 2, for example. How would things change as we went from the, I think it's lithium, and then to beryllium, boron, carbon, nitrogen, oxygen, fluorine, and then to neon. So what would be changing? The things I'm thinking about are our sizes are changing. So as we go from left to right, we're getting more electrons. So also we're getting more protons and neutrons. Everything is getting bigger and bigger as we're going across. And then I'm also curious, what do you guys think the word periodically means? So we have the periodic table, and also we're calling our rows periods. So when we hear periodically, what are we thinking about? I like to think about kind of like occasionally or every once in a while we repeat ourselves. So there's in one period we go through a activity, we go through a certain circumstance, and then once that period's over, we start at the next one, and we do the same thing all over again. So that is what I like to think of. Our objectives are going to be, we want to be able to describe what is unique about each row in the periodic table, and then be able to draw the correct electron shells for an atom as well. So I have this video. It's a great video as always. It really helped me kind of think through our periods of the periodic table and also introduce our groups and some reactivity, but it really talks well about the entire thing as a whole, so please watch that. Just some review. We mentioned this when we first talked about the periodic table, but it's always good to refresh our memories. So we have our columns in the periodic table, which are called families or groups. These families or groups have similar properties, and that's because they all have the same number of valence electrons. We remember or learned that our valence electrons are the outside electrons, and our video that we just watched did a really good job of giving us a hand motion to help us remember this. So our columns are up and down, and they have a lot to do with our valence electrons. Our valence electrons are on the outside, so we can draw a little square outside. So up and down is about valence electrons. Columns or families are about valence electrons. Then we have our rows, which are called periods. So all of our elements have the same number of electron shells in each period. So for example, in period 2 or row 2, every single atom will have 2 electron shells. So it works the same way for every example, for every row of the periodic table. And then when we think of rows, they're side to side, and then we think of shells, so we're going to make a circle with our hands like our video showed us. So those are some good ways to help us kind of remember the difference between the two. Also, we have learned about valence electrons, but we're going to touch on it again because they are very important. So our valence electrons are electrons in the outermost shell, which determine a group's ability to bond. We've been asked this before, so how many valence electrons does carbon have? We're going to only count the outside electrons, the very outer shell in this carbon. So we have 1, 2, 3, 4. Now what about valence electrons for sodium? So sodium is Na down here. Our very outer shell only has 1 electron going around in a circle. And then what about for Al over here on the right? We have 3, 1, 2, 3 valence electrons. So we're going to be talking about how these valence electrons are going to change as we go across our table, our periodic table. So we have our arrow showing us which rows we have. We have our first row, which is hydrogen and helium. Then we have our second period, I should say, not row, period, which is lithium, beryllium, boron, carbon, neon, or well, nitrogen, oxygen, fluorine, and neon. Third, fourth, fifth, sixth row gets a little bit tricky because we have this extra group down here. So when we're reading this, it actually goes 55, 56, then we jump down here, 57, all the way to 50, or well, all the way to 71, and then we go back to 72. So the only reason we have this kind of little extra part of our periodic table is because if we put it in here like this, it wouldn't fit very well on one piece of paper. So it's just to help us keep everything nice and condensed in the same area. So we can see our different rows in our picture here. So now we have we're going to look at some similarities across our periods. So each period has the same number of, the same outer valence shell. So that's saying we have the same number of shells. Rows and periods have the same number of shells. So everything in the third row, like sodium, has 3 shells, as we can see. Xenon is in the 1, 2, 3, 4, 5th row because it has 5 shells. So our first shell always can have up to 2 electrons in it. Our second shell can have up to 8 electrons in it. Our third shell can have up to 18. And then every outside shell after that can have up to 8. So we can see we can have 2 electrons, 8 electrons, 18, 18, and then 8. That has to do with the energy of each electron, and we'll talk a little bit more about that going forward on how that all works, but the important thing to know is every outside shell can have up to 8. So we can only have 8 valence electrons at a time. We cannot have any more, but we can have anywhere from 1 to 8. Alright, now let's look at some elements in our same period and how they look different. So again, our inner shell always has up to 2 electrons. For hydrogen and helium, well, really just hydrogen, it would only have 1 electron. Helium would have 2 electrons. So for elements in the same period, only our outside valence shell will change. So we can see on this inside between oxygen, nitrogen, and carbon, all in row or period 2, have 1, 2 on the inside, 1, 2, 1, 2 on the inside. But on the outside, carbon has 4, nitrogen has 5, oxygen has 6. So as we're going across, here we can see carbon is here. It would have 4 valence electrons, 5 valence electrons, 6 valence electrons. So let's draw a couple of these together. So hydrogen is our first one. It's always good to start with hydrogen. So hydrogen is up here. We know because it's in our first row, it has, or first period, it has 1 electron shell. And then because it is in it is our very first one, we only have 1 electron. So we have 1 shell with 1 electron. What about fluorine? Let's look where that's at on our table. Fluorine is over here. So we have period number 2. So we're going to have 2 electron shells. Our first shell is going to have 2 electrons because our first row has 2 elements, 1, 2. And then our second shell is going to have as many elements there are until fluorine. So we're going to have 1, 2, 3, 4, 5, 6, 7 electrons in our second shell. So let's look at what that would look like. We have 2 on the inner shell because this is for our hydrogen and helium period, and then we have 1, 2, 3, 4, 5, 6, 7. Alright, one more. What about bromine? How would bromine look? So bromine's a bit more challenging. Bromine's all the way down in our 4th period. And so, like we said, our first row is going to have 1, 2. Our second row is going to have all the way up to 8. Then we get a little bit tricky when we get to our 3rd period. Our 3rd period goes to 18, and that's because our energy level of our electrons in our groups here in this middle part of our table are the same energy level as our row above. So we'd actually go 2, 8, 18, and then this last row would be 7, because 1, 2, 3, 4, 5, 6, 7. So this is a little bit more complicated, a little bit more challenging, but I just wanted to show you guys that. This is how it works. So let's go through this again. So how many electron shells would each have in their shells? Would each element have in their shell? So if we have boron, our first shell right here. So for boron, our first shell in the first row is going to have 2. Our second shell is going to have 1, 2, 3. And since we got to boron, we're done. So boron would have, first shell would have 2, second shell would have 3. What about silicon? Let's go find silicon, Si. Si is right here. So again, first shell always has 2. Second shell can have up to 8. Third shell would have 1, 2, 3, and 4. So 1, 2, 3, 4. First shell, second shell should have 8. Third shell should have 4. Now arsenic, Ar. So this is going to be a more complicated one. We're farther down our periodic table. So arsenic, it's actually As. I have a mistake. I'm sorry about that. So again, we're going to have 2, 8, 18, and then 1, 2, 3, 4, 5. 2, 8, 18, and 5 is what we're looking for. 18 and 5. Now, if we were to add all of these numbers up, all the electrons in each shell, it should equal the same number of protons we have, because these are all neutral atoms. We've learned about how our protons is equal to our number of electrons in a neutral atom. So if we ever are unsure if we have the right amount of electrons when we're breaking it down this way, we can always add them up. For example, boron is atomic number 5. That means it has 5 protons. And we have our first shell has 2 electrons, and our second shell has 3 electrons. So 2 plus 3 is 5. 5 and 5. So we don't have any math errors or counting errors. So that's just a good way to check if we ever are unsure. But that is all I have for you guys today on the periods of the periodic table. If you guys have any questions, please let me know.